I have four properties to share with you today. The substitution property, the transitive property, the commutative properties, and the associative properties. You've seen some or most of them before, so this would be a good chance to review through those and to take notes on the stuff that perhaps you don't remember. The first one we're going to look at is the substitution property. The substitution property is nothing shocking. You've done that many times before. When someone says, here, you have 2x plus 4, plug in 3 for x and see what you get. When you plug something in, that's substitution. That's the substitution property. So the substitution property simply looks like this. If you have something like 2x plus y, and you know that y equals 5, well, you can plug that 5 in for y. So you have 2x plus 5. In symbols, if you have a plus b, and you know that b equals c, well, a plus c is the equivalent expression. That's the substitution property. Closely related to that is the transitive property. The transitive property says if you have three things, all right, let's use cans of pop here. The amount of pop in this can is equal to the amount of pop in this can. This one has 12 ounces. This one also has 12 ounces. And I come around and I say, oh, by the way, did you know that the amount of pop in the orange can is the same as the amount of pop in the Pepsi can? So these two have the same amount, and these two have the same amount. Well, therefore, if these two have 12 each, and these two have 12 each, these two cans on the outside here also have 12 ounces each. They have the same amount of liquid inside of them. And so if A equals B and B equals C, then A and C must also be equal. That's the transitive property. If we want to look at it in a little more mathematical example, suppose we have 5W equals 2P. We have a nice equation there. And 2P is equal to 17R. We have another nice equation there. Well, if 5W and 2P are the same, and 2P and 17R are the same, then 5W and 17R must also be the same, because this one is the same as 2P, and this one is the same as 2P. So it's very much similar to the substitution property. They're very closely related. The big difference is the substitution property, you don't have to have multiple equations. You just plug something in. The transitive property, you have a couple of equations. That's really the only difference there. Next up, we have the commutative properties. There are two commutative properties: commutative property of addition, commutative property of multiplication. In the commutative property of addition, it simply says if you have two numbers, say 3 and 5, and you add them together, it doesn't matter if you do 3 plus 5 or 5 plus 3. Either way, you're going to get 8. In symbols, we say A plus B is the same as B plus A. You have two numbers, 3 and 5. It's the same as 5 plus 3. The commutative property of multiplication is really the same thing. You're multiplying two numbers. It doesn't matter which order you write them out when you multiply them. A times B or B times A. 3 times 5 is 15. 5 times 3 is 15. So the order doesn't matter in addition or multiplication. That is not true for subtraction. That is not true for division. Let's take a look at two examples that use substitution property and the transitive property. We're given some information. We're told that we have 3x plus 2y equal to 4, and that we have y equals 4. That's our given information. And we want to prove or end with x equals negative 4/3. So we want to have our ending that has only an x in it. There should be no y's left, nothing like that. Now, we always begin, remember, by writing down our given information. And that's what we'll do right now. We'll jot down everything that we were given, and we'll write that it was given so that we know that. Once I've done that, what I'll do is I'll take a look at what I have. and I'm going to try to combine it somehow. I see here that I have y equals 4. And I happen to have a y right up there. So what I think I'll do is I'll plug that in, or use the substitution property, and see what happens. When I plug that in, I'm left with 3x plus 2 times 4 equals 4. I like what I see already because I noticed there are no y's left. And I saw that what I want to prove just has x in it. So that looks pretty good so far. Now let's clean it up and get the x alone. The first thing I'm going to do is take care of that 2 times 4. 2 times 4 is 8. So I will simply say that 3x plus 8 equals 4. Why did I do that? Well, I just simplified it. And because I have to justify or write everything that I've done, I'm just going to write simplify next to it, and that takes care of it. Now let's solve the equation. We'll begin by subtracting 8 from both sides. That's the subtraction property of equality. I'm left with 3x equals negative 4. Next, I'll divide by 3. When I do that, I'm left with x equals negative 4 over 3. That's the division property of equality. And what I have left, x equals negative 4/3, is exactly what I wanted to prove. So my proof is done, QED. That's using the substitution property in a proof. Let's look at one more example. I'll give you a moment here to pause so that you can finish getting down what you need to. And then we'll take a look at example 3. All right, example 3, they give us a couple of things. 2y is equal to 4z, and 3x is equal to 2y. That's my given information, and I always begin by writing down my givens. Now, if 2y is the same as 4z, and 2y is the same as 3x, it reminds me of my cans of soda, then 4z and 3x must also be the same. And so I think what I'll do is I'll state that 3x plus 4z, or 3x equals 4z, by the transitive property. You could have said substitution property, and that would be fine also. Now, when I look at my proof, it looks like what they want me to do is end up with this. X has to be all by itself on one side. So let's do that. Looks like I'll have to divide both sides by 3 to get x alone. When I divide both sides by the same thing, it's the division property of equality. And that leaves me with x equals 4z over 3. That's exactly where I want to be. And I've shown what I want to do. My proof is done. I simply state QED to show that I've demonstrated what they wanted me to. That's how you use the transitive property in a proof. Let's take a look at a couple more properties.
The other property that only works for addition and multiplication is the associative property. In the associative property, the numbers do not change as far as the order goes. Notice here I have 3, 4, 5, 3, 4, 5. What does move is the grouping symbol, or the parentheses. What the associative property says, if you're adding 3 numbers, it doesn't matter which 2 you pick first if you're adding all 3 of them. I have the numbers 3, 4, and 5. If I do 3 and 4 first, I get 7. 7 plus 5 is 12. If I pick the 4 and the 5 first, I get 9. 9 plus 3 is 12. So the associative property says it doesn't matter which 2 you add first, you'll get the same answer. In symbols,
A plus B, in parentheses, plus C, is equal to A plus B plus C, in parentheses. And the same is true for multiplication. We have our symbolic notation here. It looks the same as it did for addition, except that there's multiplication signs in there. And we'll use the same numbers 3, 4, and 5 for our example. 3 times 4 is 12. 12 times 5, 60. 4 times 5 is 20. 20 times 3 is 60. So it didn't matter which two I chose for the multiplication either.
Examples 5 and 6 are really just a couple of cute little proofs to show us that we can use the commutative properties and the associative properties when we're writing a proof. They're actually very short and right to the point. We're given 2a plus b and b equals 3. And we want to prove that 3 plus 2a can come out of what we were given. So I begin by writing my given information. And when I do that, I've noticed that 2a plus b, and I have this b equals 3. So I can plug that in to get rid of my b. That would give me simply 2a plus 3. That's the substitution property. Now, it looks like I'm almost done. I want 3 plus 2a. I have 2a plus 3. Remember that the commutative property says that 10 plus 5 equals 5 plus 10. That's what the commutative property says. And it's the same thing here. 3 plus 2a is the same as 2a plus 3. I can flip that around, and that's using the commutative property of addition. And that's what I wanted to do. So I took the little bit of given information, and I manipulated it to look like what they wanted me to show in the end. That's a neat little proof using the commutative properties. Down at the bottom here in example 6, they give me a plus b, in parentheses, plus c. And they want me to show that that's the same as a plus, and then c plus b in parentheses. In other words, can I explain how you would go from this thing up here to this thing down here by using our properties? Well, sure. And there's a couple of different ways that I could go about this. The first thing I'm going to do is use the associative property of addition. Notice that I wanted the c plus b in the parentheses, not the a plus b. But the associative property says that I can move those parentheses if I'm adding 3 numbers. A plus b plus c is the same as a plus b plus c. So I simply switched it around so that my b and my c were inside of the parentheses. That's the associative property. Now, there's still one more problem here. Here I have c plus b, and here I have b plus c. But I can change the order of 2 numbers being added. That's allowed by the commutative property of addition. So I flipped those 2 numbers. Now, notice that what I had to start with, a plus b plus c, became exactly what I wanted to end with. And so, by using the associative property of addition and the commutative property of addition, I've demonstrated that this statement here and this statement here are actually equivalent. So my proof is done, QED. So today you've seen 4 properties. You've seen the substitution property, the transitive property, and the commutative and associative properties of addition and multiplication, as well as how those can be used in justifying algebraic expressions. And that's what you need to know about these properties. We'll practice some more, and you're going to do great.